Almost 70% of our planet's surface is covered by water. It is a fundamental prerequisite for life on Earth, and plays a key role in the hydrological cycle. We learnt the basics in primary school, but it is still such a complex process, that scientists are still studying it to this day. During the hydrological cycle, water from the free water surface and evaporation from vegetation, is released into the atmosphere, where it cools and condenses, thereby forming clouds. When the size of the particles forming the cloud is large enough, they are released as precipitation to the Earth's surface. Water is then returned to the soil, lakes, reservoirs and seas, thus closing the hydrological cycle. But what exactly happens during the evaporation of liquids? When a free liquid surface comes into contact with air, the particles with the highest energy at the boundary of the two media are torn away from the liquid surface, so vapor diffuses into the gas phase. This reduces the amount of liquid, and increases the moisture content of the air. The process is influenced by many factors, which is why the phenomenon of evaporation is very complex. Such factors include air temperature, air velocity, liquid temperature, and liquid ripple, to name a few. However, we still have the question of how to determine the evaporation rate of liquids. The Department of Building Services and Process Engineering is home to the Stokes Laboratory, which offers the opportunity to study a wide range of chemical, pharmaceutical, and oil industry processes. One of these processes is evaporation, which can be studied on a convection dryer. The measuring equipment was originally designed to study the drying process, but a section was added to allow research into evaporation. The liquid used for evaporation is contained in a thermo vessel, the temperature of which can be freely adjusted to the desired value. The air is circulated by a radial fan, where the air velocity can be adjusted by controlling the speed of the fan, using a frequency converter. The air temperature can be controlled by an electric heating unit. During the measurement, a number of parameters are recorded. The temperature and humidity of the flowing air, the surface and bulk temperature of the liquid, and the amount of the evaporated liquid. Experiments can take up to hours, because of the slow diffusion processes. After knowing about the phenomenon of evaporation, let's see where evaporation plays a more important role in everyday life. Swimming pools and wellness centers can be mentioned as common examples, which everyone has encountered in their lifetime. A lot of heat and water loss occurs on these huge water surfaces, which cannot be neglected, and must be reduced, as much as possible. Preventing water evaporation also means preventing heat loss. So pools should be covered to prevent evaporation and water loss. This can save up to 150 liters of water per square meter per month, not to mention the associated costs. The phenomenon of evaporation can also be encountered in industrial conditions, as one of the most spectacular elements of a thermal power plant is the cooling tower. The task of these giant structures is to cool down the hot cooling water used in the factory, with the help of air. The heated water is introduced into the cooling tower through a distribution head, where it comes into contact with the cold air through the inserts. Then the water cools, and a part of it evaporates, while the air heats up, and takes the evaporated water vapor with it. This leaves the tower in the form of white smoke, which can be seen from several kilometers away. Nuclear power plants should be mentioned, as a slightly more special example for evaporation, as nuclear spent fuel pools are located here. The fuel rods removed from the reactor are stored in these pools, until they are completely exhausted. These fuel rods can reach 2,800 degrees, and in the process emit very harmful radioactive radiation. The boron solution water continuously circulated in the pool prevents the effect of harmful radiation outside the pool, and cools the fuel rods. So it is vital to keep a constant supply of water, which can evaporate into the air, and thereby can disrupt this delicate process. Some of our fresh water is stored in huge reservoirs, which are essential for preventing our water needs and supplying drinking water. The amount of fresh water available is limited, so protecting it is our primary task. Since these huge open water surfaces are in continuous contact with the air, evaporation is also significant. This is such an important problem, that in America, a reservoir in California was covered with black, plastic balls, to prevent evaporation. 96 million balls were scattered over the surface of the reservoir, which inhibits evaporation, algae growth, and the formation of toxic bromate. In this way, they successfully prevented the evaporation of 13 billion liters of water per year. It can be seen that evaporation plays an important role in various processes, and in our everyday life.